Hello, everyone, and welcome to my lab report for lab number 5. In this lab, I observed the motion of an object that was moving at the same speed without changing direction. I compared the position of this object, which is a cat toy, as a function of time for an experimental measured position and a computational model predicted position. And I utilized Newton's second law to determine the computational model predicted position. I found that the model's position matched up very closely to the experimental position in the beginning. However, at the end, there were some differences. So here's Newton's second law, and this, assuming that the velocity is constant, then the velocity final is equal to velocity initial. And that means that the F net must be 0. And the position can be calculated with this equation only if the F net is 0. So for my experimental observations, I did this video of a cat chasing a cat toy, and I measured the position versus time of the cat chasing the cat toy, and I did the position versus time of specifically the cat toy. And so from this, I found my initial position and then the time at 0.04 seconds to calculate the initial velocity. And then I also have the mass of the cat toy and the last time of observation. And then in order to, or it's useful to calculate the initial velocity because if the cat is chasing the toy, then the cat is going to have to go faster than this in order to catch up to the toy. I set up the axis where the positive x direction went to the right. This caused the initial velocity to be in the positive x direction. And for my computational model, I use GlowScript, and this is where I applied the mass of the ball, the initial position, the ball's initial velocity, and then for this time interval, I applied Newton's second law here. That's basically that the ball's velocity equals the velocity of F net, or velocity plus F net divided by ball's mass times delta t. And then also the ball's position equals ball position times ball velocity times delta t. And then when you run the program, this shows the ball moving in this direction as position of time or position versus time, and where the initial velocity and constant velocity is 54 centimeters per second. And so to compare the two, this is how it looked at comparing the experimental to the model. So you can see the experimental towards the end is different than the model because the experimental slows down due to friction. And so the actual velocity is not constant with the experimental, whereas the model would predict what it would be like if it were constant. And this is just sort of showing how friction is pushing against the ball, which slows it down. So if the ball was rolling this direction, it would be slowed down by the friction. And thank you so much for watching my lab report.